Hi, good morning, everyone, and welcome to this webinar. I'm Nicolas RUIZ, Research Department Manager at France Energy Marine, and it's a pleasure to be the chairman of this session today. This webinar is organized following the closing of AFOSS-DC GIP, conducted by France Energy Marine and supported by France National Research Agency, Région Pays de la Loire, Région Occitanie, and Région Sud. This project has involved several academic and industrial partners during the last 3 years and focused on the design of future floating electrical substations. So today, several partners involved in this project will present the main achievement and result, and our speakers will be Johan Perchet, hydrodynamic engineer at Atlantic Offshore Energy, Jeremy Bew, who was the project manager of this project from France Energy Marine, and Jan Giorgiotti, naval architect at RTE, which is the French TSO. Here you can see the agenda of this session today. So after a brief introduction and context presentation, Johan will present the main results regarding the work conducted on topside general arrangement and outcomes of the semi-submersible floater design. Then Jeremy Bew will present the result on TLP technology of floater and the feedback on design and basin test campaign. And at the end, Jan will present the vision from a French TSO regarding the perspective of floating offshore substation. So during the presentation, you can post your question in Teams application by using the Q&A windows located on the top of the screen panel. And we'll address all the questions after the technical presentation in the Q&A session. And we, after, close this webinar. So before the technical presentation, just a general presentation of the context. So why we're looking for floating solution for substation? We all know that coastal areas are well used with a significant coactivity also, and sometimes acceptability issue. So this is the reason also why we're looking for higher water depth far away from the coast. And for this case, we need to switch to floating solution. And for substation, we need to have a look on the feasibility to using floating system, in particular in the view of constraint imposed by electrical component. And in research action, to also try to optimize or find the best solution of floater that can be used for this specific application. And in the meantime, as the tendency is to increase the wind power of wind turbine and then the global power of the farm, from a certain distance between the connection point, offshore and onshore, we also need to optimize to reduce and optimize the electricity losses. And we know that these losses will increase with the distance, and particularly in a HVAC solution. And this is the reason why we're looking for also to initiate some action, innovative task regarding the HVDC export. But in order to be able to do that, we need to integrate new component that can be sensitive to motion or vibration. And this is the reason why we analyze that. So for all these reasons, we initiate the AFOSS-DC GIP to address several of these topics. During the project, we first work on a design basis in order to select several locations in Europe and worldwide with associated meteorological condition as base case for analysis after. We work on electrical architecture definition as well as topside general arrangement. Based on this topside definition, we analyze both solutions of floating semi-submersible and tension leg platform. We also perform a dynamic cable arrangement, including EAC and export cable. We also address cybersecurity and conduct risk and reliability analysis and maintenance optimization. And at the end of the project, we initiate some work regarding the validation qualification strategy and also identify the rule and regulation gap analysis.